Hey Ram, how are you?
Hey, hello Naveen. I'm good. How are you?
Thank you. Thank you everyone for joining. So this is our first YouTube live from QA Insights. It's been a long time since we met Ram in Clubhouse. So at that time, I think we decided to go have some live sessions uh, to learn more about JVM performance, Java performance, and learn about what yCrash is doing. So today is the day. So I've been planning this for a very long time. Ram is also a very busy person. So at last, we got some time to sit around and learn something new from Ram. So thank you for joining, folks. So please add your comments. Just let me know where are you from and what are you doing, what tools you are learning right now, so that I can just get started with the conversation, and then we can directly go into the topic. So this is our first live session. So please apologize for any mistakes. We are all here for learning. Thank you, Mahalakshmi, for joining us. Thank you. Okay, thank you, Ram, for joining. Please introduce yourself again, and
Okay.
yeah, let us get started.
Okay. Hello, friends. First of all, Naveen, I'm a fan of your work, what you have been doing to the performance engineering community. Thanks for giving me this opportunity. And also, hello, friends, whoever is joining from the YouTube live. First of all, thank you. It's a weekend. Still, you're taking a valuable time to come and be part of this discussion. Thank you very much. So I'm Ram Lakshmanan. So I'm the architect of yCrash and GCEC Fast Thread and ePiro. So these are the JVM troubleshooting tool set. So so I'll leave it at that level. I don't want to be talking more about me. It is
Sure.
more about how we want to learn and share the knowledge.
Yeah.
Mhm.
Yeah, we have Harsim Ranjit Singh who joined us from Singapore. Thank you, Harsim Ranjit. And we have Ajay Krishna. Hi, guys. Thank you for joining. And we have again Sid. Sid is a very long time listener in Clubhouse. Thank
Okay.
you, Sid, for joining us again. Yes, Ram. So today, what we are going to discuss, what people are going to learn from you.
Yeah, so the topic is scale your JVM performance, right? And that's what we are going to be talking about, right? Uh-huh. So what you can do, I'm going to share some very simple techniques, but which can have a very profound and very deep impact in scaling your JVM performance. So that's what we're going to be discussing about.
Sure. Thank you, Ram.
Mhm.
So we have Pawan from Bangalore also joined us. Thank you, Pawan, for joining us.
Mhm.
Thank you. Thank you, everyone. Yes, Ram, we can share your, you can share your screen and then we can get started. So please
Okay.
post your questions in the YouTube chat. Uh, Whenever Ram gets a chance, he will address it.
Yeah. No. Yeah. So friends, feel free to ask question at any point in time. And I mean, in case I'm not looking at the chat and I'm doing a presentation, feel free to stop me and then let me answer the questions. Okay.
Yeah,
Okay.
yeah, sure.
So, friends, Java virtual machine, right? If you see, Java came into existence in 1995. It has been 27 years since then it has passed. But if you see the Java virtual machine, at the bottom of Java virtual machine has been changing significantly. Earlier, Java virtual machine was just used to run on a bare metal and there was operating system and then it was running. After that, it became VMware and then it became containers, Kubernetes. So what is going behind the JVM is changing. And if you also see what is above the JVM, there was web applications. In fact, it started with applets. No one know about applets anymore. And then it became web applications, web services, microservices, IoT application, mobile applications. It is evolving at the top, and it's evolving at the bottom. But if you see, friends, the Java virtual machine is more or less the architecture of JVM. What it was 27 years before and what it is now is still the same. It hasn't. It has changed as it has evolved, but it hasn't drastically changed. And in fact, friends, when you master this JVM tuning and JVM performance engineering, you are not only optimizing the Java language's performance. Today in Java virtual machine, 52 programming languages are running. Scala, Python, JRuby, Kotlin, so many languages are running. So if you learn to optimize and tune the JVM performance, you're not only optimizing your Java applications performance, you can optimize the performance of all these 52 applications. And this skill, even though it's very, how do I say this? It is very overlooked. Like it is kind of a black box to so many of them. See, if you see what is below the JVM, there are a lot of experts, Unix administrator, Linux administrator, system administrator, the Kubernetes experts, everyone is there. If you see above the JVM, there is application architects, Java gurus, and everyone is there. But this JVM is still a black box for most of the people. And so if you can master this skill, it will be a very lifelong, very valuable skill you're going to acquire, right? Okay, having said that, now let's get into the session. So friends, if you want to tune the JVM performance, there is few things you can do, but the one primary thing, what if you can do, which will scale your performance, is garbage collection tuning. That is a garbage collection tuning. If you can just learn just this one thing, it can give you a very significant, profound impact to your application performance, right? So how does garbage collection tuning can give such a big impact? See, before I embarked on this JVM troubleshooting and performance engineering journey in my career, I always used to think, okay, garbage collection is automatic. Uh, it's automatic in Java and almost all programming languages which is coming out now. And it only pauses for a few milliseconds. The garbage collection pauses the application for a few milliseconds or few seconds. Why people are talking big deal about it? What is big deal to it? It's just pausing for a few milliseconds or few seconds. Why there's so many literature? A lot of people are talking in the conference. Why is it a big deal? I had that question. Some of you who may be listening here may also have that question. But now, as I start to get into this journey, now I'm becoming. It looks like a huge mountain in front of me. What that garbage collection is. I'm starting to respect that. It is such a profound thing. And let me say why it is such a profound thing. Through some real examples. Uh, okay, Lalita says that's what she is also thinking. Okay, Lalita, let me know what I'm going to be sharing now. After this, whether it changes your opinion. Okay. So we always think, a lot of people say, yes, garbage collection is automatic. I don't have to worry. Is it true? Right? Let me share with you a few things. Okay. Friends, this is an exercise that has been conducted by a very large automobile company in the world. I cannot say that name, but if you think about a very largest automobile, one of the largest automobile, if you think in your mind, if you think 2-3 names, this will be one of them. So this is their middleware platforms response time. This is the entire middleware platform response time, nothing to do with garbage collection. So their baseline response time was 1.88 seconds. This is what the response time, what their middleware customers were getting, right? 1.88 seconds. And then the transactions were the 0.7% of the transactions were taking more than 25 seconds and they were timing out. So this is what their baseline setting was, right? So this automobile company, and this is since being a middleware, the performance is very critical and availability is also very critical, and it processes several millions of transactions. Okay, so by doing the GC tuning, right, by able to do the GC tuning, look, they did a few iterations. They were able to drop down their overall applications response time, not just 1 or 2 transactions response time, the overall application response time from 1.88 seconds to 0.95 seconds. This is like a 49.46% improvement. And then look at this, the number of transactions which was taking more than 25 seconds, earlier it was 0.7%, and now it has dropped down to 0.31%. Friends, there are a lot of performance engineers in this call and who are going to see this in YouTube. Just take a moment and think through in your career, how many times you have seen your overall application response time to be optimized. Just take a pause and think through in your career, how many times you are able to optimize or you have seen the response times to be dropped. And not just, see, we might have dropped one or two transactions, one or two key transaction response time because of maybe by tuning the SQL query or some refactoring some code. Yes, one or two transactions you could have done, but overall application response time, how many times you would have done. And friends, another thing, even if you have done, you can finger them out, right? Even if you have done that, it would have been always involving a code refactoring, uh, change to your architecture or any infrastructural improvements. Maybe you went to a different database, different cloud provider, or a different architecture, right? You could have gone through these things. So either it is code refactoring, re-architecture, or infrastructural changes. All three are very expensive and very intrusive, and there's no guarantee on return. It's basically it's a high risk change. But with this GC setting tuning, what you are doing is I'm only changing the JVM arguments that I'm passing to my application, nothing else. No, you're not changing a single line of code. I'm changing the GC arguments. Only I'm changing arguments that I'm passing to JVM. With this, they are able to achieve. This is one of the profoundness of garbage collection tuning, right? This is just the first point, what I want to make it. And the second point, through garbage collection, your application is wasting anywhere based on your organization size. You are wasting anywhere from thousands of dollars to several millions of dollars. Garbage, because of that, major applications are wasting several millions of dollars. How is it, right? So let me talk about it. So for that, here I published this white paper. Let's get into the detail.
Ram, before we go into that,
Sure.
yeah, Harsam Ranjit is asking, there are more than 100 parameters in JVM, so he wants to know which parameter to tune.
Okay. So Arshan, it's not 100 parameters. Just around garbage collection and memory to JVM today, you can pass 600 plus arguments. There are 600 plus arguments, right? JVM has been in development for last 27 years, and people have been adding, and there is different GC algorithms, right? So we will talk about it in the later part of the session, right? Okay. Okay. So now let's come back here about the financial impact what garbage collection is causing to your application, to your organizations, right? So friends, when you come to GC tuning, right, the garbage collection tuning, there is one metric what you study for to study the performance of garbage collection. There is one metric you study, what is called as a GC throughput, right? This metric is reported in percentage. I don't know who is that person who came up with this idea to report the GC throughput as a percentage. He's super clever, he's super smart, but actually it is very deceiving. It is very deceiving. Let me explain what it is. See, someone might say, I will explain how to get your application GC throughput and all in few minutes in later. But first, let's understand the concept. So this application, right? Say suppose if someone says my application's garbage collection throughput is 98%. What does it mean? What does the 98% throughput means? So I'm asking, let me ask the friends in the who's listening, how does it sound to you? If a GC throughput is 98%, how does it sound to you, right? For most of us, 98% means it sounds like a good number, right? Because if my daughter who is in high school, if she gets a 98%, then I'm very excited because it is a A plus grade. It's a A grade. Our human mind has been trained to think, yes, anything about 90, 95 is supposed to be a very good grade, very good mark. So we think it's a very good percentage. But look at this. If someone says this application is 98%, what does it mean is this application is spending 98% of its time in processing customer transactions. See, when garbage collection runs, it pauses your application. It freezes your application because uh, when new request comes, it creates objects, and the garbage collector has to run and remove that. Once the request has been serviced, the garbage collector has to remove the unreferenced objects from the memory. To do that, it pauses your application, right? So when it pauses, if any new transactions comes during that time, it's not going to get back any response. So garbage collection pauses your application. So when someone says his throughput is 98%, it means that the application is spending 98% of its time in processing the customer transactions, and 2% of time in processing garbage collection activity, right? Because to do the garbage collection, you have to pause the application. So that's what it means. So if your application is 98%, throughput is 98%, then let's look at the math. How much in terms of physical time it's being spent? In one single day, there is 1440 minutes, which is basically there is 24 hours multiplied by 60 minutes, right? There is 1440 minutes. If someone says if throughput is 98%, that means 2% is spent in garbage collection. What is 2% of 1440 minutes? It is 28.8 minutes per day, right? So this is just one JVM. Say if your application is running on 10 JVMs, then multiply this 28.8 minutes by 10, right? But now let's coming back here. How does this 28.8 minutes sound to you? What does this 28.8 minutes means is it's almost half an hour. Half an hour in a day, your application is doing garbage collection. See, garbage collection is not helping my customer. It is basically housekeeping task. So it is not servicing my customer. But actually what is happening is during this half an hour window, if any request comes in, your application will not respond back to your customer. Your application will not respond to your customer. It means your application is sleeping. When it has to work, it is sleeping. And if it is 28.8 minutes per day means, what does it translates in 1 year? It translates to almost, I think, seven plus days. For 7+ days, your application is sleeping while it has to work. For any request that comes during that time, it's not going to get any response. It just because your application is doing garbage collection, it doesn't mean your cloud provider is not going to charge you for that 7 days. The cloud provider is still going to charge you, right? And friends, one more thing, why this is not a big thing is, and first of all, let me say, be glad if your throughput is 98%. Be glad if your throughput is 98%. Uh, okay, look, let me show you. This is I'll tell how to get all these metrics for you. So this is an
Ram, sorry to interrupt. So Harsim Ranjit is telling that 28 minutes or in one shot.
no,
So
no. That is a good question. Actually, that's a good question you're asking. It's not 28 minutes cumulatively your application is pausing. This, if throughput is 98% in one day, it means there's 28 minutes is split all throughout the day. That's what it means. It's not pausing for 28 minutes together. See, if it is pausing together, yes, it would have got to visibility. But what happens is your application runs through fine for, I don't know, 5 minutes, and then it pauses for a few seconds, and then once again it runs, and then it pauses. Think through, visualize maybe your dream car, right? You visualize any your dream car. Let's say you bought that car, and now you're taking it for a drive. How will be your experience if the car drives for 10 miles and then it stops there for a few seconds in the middle of the road, and then once again it drives for another 10 miles and then it stops there for a few seconds and then it drives? That's what Java virtual machine is doing. It just because it is not a physical object that our human eyes cannot see, we are not visualizing, but this is what is happening under the scene. And this is not just Java virtual machine. All modern programming languages does this because of automatic garbage collection. Because earlier days, when it was a manual collection, the developers were coming, it was developer responsible to release the objects, but it had its own side effects. I'm not going to be talking about those things now. So automatic garbage collection is a good thing. I'm not saying it is bad, don't get me wrong, it is a good thing, but you got to tune it right so that the pause times are minimized, so that your car keeps running with very less pause times as possible. So that's what it is.
So Ram, Pawan is stating that 98% is good, right? So why we should
No,
focus on?
I'm not saying 98% is good. See, is 98% is good. If 98% is good, your application is pausing for 28.8 minutes per day. That means your application is freezing. It's not servicing any transaction for 28.8 minutes. So I'm not saying 98%. 90% may be okay, but you should shoot for something better.
Sure. So Ram, every cloud provider, right? They have some SLA, right? 5 nines, 9 nines, something like that, right? So do we
Right.
have any standard for the GC throughput? It should be like 99.999 something. Is there
No,
any number?
see, there is no such standardized metric which is there for this. But in my opinion, if you say a 99 plus or a 98.5 plus or something, then it's better, right? But let me show you, since you touched upon a cloud provider, right? Uh, no, I will hold on to it. I'm going to be sharing with you a GC metric of a cloud provider itself, their GC problems, right? We'll talk about it as we progress along. Okay. I don't know how they can guarantee 99.99% availability if they themselves are having a throughput percentage of 96%, right? Okay, let's talk about it later. But let me do the mathematical calculation right now, right, of this impact. Let's come back here. Okay, so friends, look at this. Let's just focus on this column, the second column, right? This is what I'm doing, a dollar value. I'm assigning a dollar value to it. So if your application's throughput is 98%, right? If your application throughput is 98%, that means amount of minutes wasted by one single JVM, just one single JVM. Your application might be running on 100 JVM, 1000 JVMs. Sometimes you are a massive corporations where I have seen like you're running on a 200,000, 300,000 JVM. These all exist. But just for one JVM, if your throughput is 98%, that means your application is pausing for 28.8 minutes. It's pausing for 28.8 minutes. So that means for 1 hour, sorry, for 1 year, this is for per day, it's 28.8 minutes. So that one JVM, how much time it will pause for 1 year? That is 28.8 minutes multiplied by 365 days. It is nothing but 175 hours. This is what amount of time it pauses. That means for 175 hours, if any request comes during your time, the customer is not going to get any response. What is the dollar value of this? What is the dollar value of 175.2 hours, right? Say you are a mid-sized corporation and you are running on 1,000 EC2 instances. Say from Amazon, you got 1,000 EC2 instances, and let's say for my calculation, I've used the US West North California region, and I'm saying I'm doing a calculation based on a T2 2x large 32 gig machine, a 32 gig machine. Your machine, if it's going to be bigger, the cost is going to be much bigger also. So the cost of a T2 2x large 32 gig Red Hat Linux machine in North Carolina, in North Carolina region is 57 cents. That's what it is. So if I'm going to multiply this 57 cents with 1,000 EC2 instance for this many hours, the cost is 100,000 US dollars. This company, that means it is paying 100,000 US dollars for nothing, because your application is garbage collection, it is sleeping during the time, but it doesn't mean your cloud hosting provider is going to give you a discount for that. He is going to continue to bill for it. So it is 100,000 US dollars. But let's say you are a large corporation like financial institutions or technology service providers. You're running an 100,000 EC2 instance. Then your cost of, if your GC throughput of 98% is 10 million US dollars. Be happy if your throughput is 98%. I've seen trading applications, several other people who is having a throughput of 95%. If your throughput is 95%, if you're a large corporation, you're talking about burning, literally burning 25 million US dollars. And one sad part is all the management, all enterprises, they try to cut down the cost in small places. Here there is a big place where money is getting burnt, and the sad thing is it's getting burnt without even the knowledge that it's getting burnt. By doing this GC tuning, you can bring this cost saving to your organization, right? And that too, this is a recurring cost, my friends. Every year you are burning this cost, right? Okay.
Ram,
Now let
do
me.
we have any use case? I mean, a white paper kind of a case study. Any organization which they reduced these cost?
See, look at this. Here I'm sharing with this is the whatever I shared here is the real response time impact of what has been done with this. So the throughput also also has increased with it, this one. So see, there are so many use cases, like say Uber is our customer, and their white papers have been published. And then there is this CloudBees, and there are a few more other organizations whose white papers have been published, but the dollar equivalent has not been put in, factored in there.
Got it.
Okay.
Cool. Yeah,
Okay.
Pawan is telling that
Hmm.
will moving to other resources like Lambda reduce this cost.
No, it will still, if it's a Lambda function, still the Lambda function is running on a JVM. So JVM is still going to pause. Okay. So now coming along, so the garbage collection is not, we talked about the response time impact, we talked about the cost, but the garbage collection is very profound in predicting the performance characteristics of your application. See, today world has seen cutting edge monitoring tools like App Dynamics, Neuralink, Wiley Introscope, Nagios, Datadog. There are so many cutting edge monitoring tools. They are very good, right? But they always monitor the macro metrics. These macro metrics, they tend to report once the problem has happened. They tell, okay, once the CPU has spiked, oh, the CPU has spiked. Once the memory has degraded, oh, the memory has degraded. They are good at telling. But if you start to monitor the GC logging, it can predict the outages to you. You can forecast the outages, what you're going to suffer. Let me see. Let me pull up that blog for you, and let's discuss that.
Arsim Ranjit has a comment.
Hmm?
You can read it in the screen. So I will read it for you. So he's stating that the users will get a delayed response whenever this is happening, when the request comes through. So the users will get a high response time, right, Ram?
Yes, exactly. Answer is yes. Answer is yes. So say sometimes it's possible that customer might say, oh, your application was responding good, but all of a sudden you didn't get any response. But few seconds later, it started to resume properly. Maybe it could be very possible the garbage collection event is running in the background. Then that behavior is very well, like, that's why that is one of the possibility for that experience. Yes.
Good. But when the out of memory occurs, so that particular
Hmm?
JVM will be killed, right? So in
No,
that time,
no. Actually, it's a misnomer. When out of memory error happens, the JVM doesn't die by itself. It could be possible that JVM doesn't die if the out of memory error happens. Only the thread which was working, if it got out of memory error, actually, out of memory error is a self-defensive mechanism introduced by JVM to protect itself. Because say there's a rogue thread, the rogue thread is executing some object and creating objects infinitely. Then if memory limit is reached, that thread will experience out of memory error. When that is experienced, that means the thread will back off from what it's working on. So only that thread is thrown away from execution path. The JVM will not crash. It's a misnomer that it's out of memory error crashes the application. But anyway, go ahead with your question, Naveen.
yeah. So
The
I mean,
clarification.
yeah. So in that time, the users will not see 500 error, right?
They can.
Okay,
There's a possibility exists. Yes, they can.
got it. Cool.
Okay.
Thanks, Ram. You can proceed, please.
Okay. So friends, this is an garbage collection behavior graph of a very healthy application, right? You can see the request comes, the memory keeps building up, and then a full garbage collection event runs, and the memory drops all the way to the bottom. And then the request comes, the memory keeps building up, a full garbage collection event runs, and the memory drops all the way to the bottom. I can see this beautiful sawtooth pattern. You see, that's a beautiful sawtooth pattern. And look at the bottom points of where it comes. I see here it is dropping here. It is almost like a 50 MB, right? That's what it is. Now, look at this pattern, my friends. You see the request comes, the full garbage collection event runs, and the memory drops here. Look where it has dropped for the first time. It has dropped to 22 gig. And now as request comes, the memory keeps building up, the memory keeps climbing. And now towards the end, look at this, what's happening. It is dropping to 32 gig, not to 22 gig where it has dropped. So this is telling this application is suffering from an acute memory leak. It is suffering from a minor memory leak, but not aggressive enough to go ahead and crash. But if this application is going to run for a prolonged period, then it will crash. It will crash. But right now it is kind of experiencing a slow memory leak. So if this application is going to keep on running for some more time, it will crash. And friends, people uh, talk about machine learning, all those great words, great algorithms. But there is one very simple high school mathematical formula, which is also considered as a machine learning. That high school mathematical formula, what we learned in our high school, is slope. What is the formula for a slope? Y is equal to mx plus b, right? It's a formula for the slope, which will detect me the slope. Look at the slope of this graph, right? Of this bottom point. It is at a 0 degrees. It is going to 0 degrees. This one, it goes at a 26 degrees. Look at this black line. It is going at 26 degrees. So it's not zero. If it's not 0 degree, and if it's going 26, 35 degrees, it's going, then it's confirmed that this application is going to crash, right? But so this is kind of, I can predict the very way ahead. But now this is not of interest. But let me show you. This is an interesting graph. You see the here the memory coming, going up and up and down. Look what has happened here. Towards the end, the red triangles means a full garbage collection event, which is a full pause. It is happening, the application you're doing. Here, when it does the full pause, I can see the full pauses are running repeatedly again and again and again, but the memory is not dropping. Memory is not dropping here. So this means, and friends, first of all, I want to tell you, when a garbage collection event runs, it pauses your application, and not only pauses your application, it consumes enormous amount of CPU. It consumes enormous amount of CPU. Modern application creates tons of objects. Even to service a simple vanilla sign-on request, you may be creating 10,000, 20,000 objects in the background. Yes, it is that much. It is. We will talk about it if time permits in this session. You're creating tons of objects. So now the several thousand objects which has been created, some now a garbage collector, look what it has to do. It has to investigate all these several thousands of objects in the background to see whether there are any active references. If there are any active references, it has to go whether those references has any references. And if they're not having any active references, then it has to be sweep them out. To do all these things, only it is pausing, and to do all this computation, it consumes enormous amount of CPU. And friends, I can say with all confidence, say today if your application CPU utilization is 60, 70%, the garbage collector might be taking like a 30, 40% of it. Yes, because garbage collector has to investigate all these objects what you created, and then it has to constantly keep checking. It is a lot of computation, a lot of mathematics. So it's a heavy amount of CPU is consumed. Look here, the CPU consumption around this time frame and all would be 99%, because garbage collection is running repeatedly again and again and again. And friends, if you deployed your application and all of a sudden the CPU started to spike up, you may want to look into garbage collection behavior. Maybe this is the pattern might have been happening. It's quite possible, right? But why? Let's get back to the predictability, the forecasting aspect. Look here. Here, the repeated garbage collection, the red triangle, started to run around like, let's say it is like at 6:15. It's starting at 6:15. But you will get the out of memory error when you hit the ceiling limit, which is like a 35, 40 minutes later. But this repeated garbage collection started happen very early, way ahead in the game. So the one micro metric that what we monitor is called as the same metric, the GC throughput percentage. During all these healthy time periods, your GC throughput would be like a 99% or 98%. What is the normal throughput you are experiencing? But once you get into this danger zone, the throughput will start to degrade from 99, 98%. It's going to degrade to 95%, 96%, 90%, 85, 80, 75, 60, 65. It's going to start to degrade. So the moment you see the GC throughput, because look what it's doing on this time, it is only doing garbage collection. No customer transactions are fast. Your application pretty much became a zombie process, unresponsive at this time. So if your throughput starts to degrade, that's a very great micrometric, a very great predictor to detect, to say that you're going to have an outage. So using garbage collection, you can predict outages, right? Okay. So this is the third benefit I want to highlight. And the fourth benefit, what I want to highlight and bring it to your visibility is.
I'm sorry to interrupt. Before we
Sure.
go, can we take some questions?
Sure. Most welcome.
Yeah, Pawan is stating that cloud found instances where instances crashed, which is due to heap memory issues. So,
Hmm?
any comment on that?
Yes. So, friends, if it has crashed due to heap memory instance, we have to do a heap dump analysis, a memory dump analysis, right? Uh, if you would have crashed with heap memory issues, if you see the garbage collection behavior, your graph would look like this. Your graph will look like this. The graph will look like this. But it will, once you see this kind of a pattern, and what you want to do is you want to capture the heap dump, and then you want to do the analysis. See, that is also part of the JVM troubleshooting, but that needs to be a separate topic, right? Can't be spoken in this session.
All right.
Okay.
Okay, so we have next question from Sid, I guess. So, how
Mhm.
does JVM or GC tuning related to Java versions in terms of performance?
Hold on to that
Means
question.
every new Java version has to be performant in terms of performance.
Hold on to that question. We'll talk about it, right?
Okay,
I'll
cool.
answer that question. Okay. Any other questions?
No, Ram, please proceed. Thank you.
Okay. Okay. So the next benefit, what you get by doing this garbage collection tuning is you can do effective capacity planning, right? So let's look at it. See, friends, this is an real world data of a very large security service provider, right? I cannot tell their names, but it's a very large security service provider. See, they have configured 48 GB as their XMX, the heap size for their application. 48 GB as their heap size. When someone does the capacity planning, or even this is for from the cost saving perspective also, oh, if this is set, we always assume that is the right value. No one has the guts to go and question that value, whether this 48 GB is the right value for my application. No one has that guts because it is there, it's taking traffic. We are afraid to go and touch. But when you do the garbage collection study, that will actually tell whether you actually need that 48 GB or not, right? This security service provider, they configured 48 GB, and these were their metrics. Their GC throughput was 99.95 percentage, and then the pause time was 218 milliseconds. The maximum was this much. When looking at the garbage collection behavior, never it cost it didn't need more than 12 GB even during the peak time, right? So when the metric, so then when they dropped it from 48 GB to 12 GB, right? And look at it, the throughput is almost same, and the pause times in fact has gotten a little better. So the garbage collection can tell whether what you have set is the right number or not. If not, you can drop. Look, now by dropping 1/4, look what is the kind of the cost savings you are going to run. You don't need to run on such a large EC2 instances. You can run on a much smaller EC2 instances, and this can bring in a very profound cost savings, several millions of dollar cost savings, right? Okay, so this is another benefit.
We should not
So
over-allocate anything, right,
right,
Ram?
we should over allocate. In fact, we don't. People doesn't even know whether we're over allocating or not. You only know whether you're over allocating or not by studying the garbage collection behavior. That's the
Okay.
point I'm
We
trying.
have Raman was a question
Hmm.
about can we capture the heap dump after application crashed?
No, no, because you need to capture the dumps when the problem is happening. Right when the problem is happening. This is only one common conflict I have seen again and again. Because of the heat of the moment, the support engineers they go and restart the application without capturing the artifact. Whereas the the development managers will question them. So why you guys didn't? Why you restarted the application and captured the dump? It's not useful. It's not helpful. So you need to capture when the problem is happening. Since Raman has touched upon that, let me quickly highlight to you. There is an open source script that I want to share it with you. It may be helpful to you guys. See, uh, and Raman, for your question, there is one JVM argument called as heap dump on out of memory error, right? When you pass that argument and you can give a file path, what will happen is when out of memory error happens, automatically the heap dump is captured and returned to the file system. It's called as a heap dump out of memory error and heap dump file path, right? You can pass those two arguments. When that happens, when out of memory error happens, automatically it is returned to the disk. So in that case, that is one safeguarding approach for you. Okay. But now
And
since
then,
Ramana, hmm?
yeah, so yeah, Harsim Ranjit regarding the heap size allocation. So
Hmm.
he's telling that do we need to try and see what is the best heap size? There is no formula for that.
Yes. So you want to look into your garbage collection behavior, and then you have to lower it, and then you want to study and see. There's no mathematical formula to that, my friend. Okay. So friends, in the interest of time, there's only another 20 minutes left. So I want to get about how you can do the GC tuning a little bit, right? I can share some few effective tips, right? Okay. So before that, since Raman asked this, see friends, when a problem happens in production, I don't know where it happened. It can happen because of all we see is the CPU spiking up or unresponsiveness or memory degrade. There could be several reasons why you're getting a poor response. Maybe there is a network issue. Maybe there is a slowdown in the database. Maybe there is a garbage collection pausing. Your threads are getting into the block state. We don't know what it is. So here, when the problem happens, we have written this one. It's an open source script. It is platform agnostic script. You can download it, and then you can run it. You don't need to install anything, right? And then you can go ahead and run it. So that script is called as a yCrash script, and so this is how it is. So this is all you trigger .yc and give a Java home and give this argument only capture and minus p process ID, the process ID which is sick. When you trigger this script, what it will do is it will create a bundle zip file. It will create a zip file like this with a timestamp, and this zip file will contain a 360-degree data about an entire application stack, like a GC log, thread dump, heap substitute. All these things are there. Dmessage, kernel logs, kernel parameters, network statistics. Everything is given to you for analysis. So this you may find it helpful. Okay. So having said that, let me switch back here. Let me just give you a quick recap. Garbage collection, we always think, okay, it's pausing for a few milliseconds, few seconds. So it may cause some unpleasant customer experience only for that momentary period. That's what we all think, and that's why people look at tuning. No, that is just one of the least impact benefit you get by doing garbage collection. There are so many other major benefits. You can save millions of dollars in cost saving. You can improve your response time, overall application response time, with very low risk approach. And then you can do predictive monitoring, you can forecast outages, and you can do an effective capacity planning. You can see whether you over allocated resources, right? So these are some of the 5 primary benefits. There is more to add, but I'm not going to go into the details, right? Having said that, now friends, let me share with you few tips and tricks on how you can go about tuning or your GC performance in your application, right? So
Ram,
okay,
that the script you shared, right? Will it work for all Java version?
yes, it does.
And is it available in GitHub? Pawan's
Yes,
question.
it is available in GitHub. You can look it up in GitHub. It is available in GitHub. You can look it up, and we have given the link here. You can pick it up. Yes. Okay. So now I'm going back here. See, friends, there is. It goes back to our friend's question about right. People are asking about how to go about tuning, what are the different GC algorithms, what are the different garbage JVM arguments you can pass, right? I'm going to be talking about those things briefly. So, friends, there is today in Java 11 plus version, there is actually, if you take the hotspot JVM, which is the Open JDK or Oracle JDK, there is 7 GC algorithms: serial, parallel, CMS, G1, Shenandoah, ZGC, Epsilon. And let's say if you're going to go for some specialized JVMs like Open J9, they have their own GC algorithms. If you're going to use for Azul JVM, they have their own GC algorithm. So there is multiple GC algorithms, and there is 600 plus JVM arguments you can pass just around the garbage collection and memory, right? So how will I know what arguments for what GC algorithm, which GC algorithm to choose, right? And there's not much lack of literature and all of things. See, uh, this is someone who is trying to understand garbage collection. Before, he used to have a lot of hair, and then after that he started losing hair. So so it might be overwhelming for anyone, right? But friends, let me tell you, you are not alone. Garbage collection tuning may be overwhelming, and you are not alone. In fact, me, who is doing this for a living, in this 600 arguments, if I know 5% of the arguments, I don't even know more than, I just know only 5% of the arguments, right? And it's not just I just know a little bit than what you guys know. That's all I know. But I do this for living. And friends, but it's not just you who is overwhelmed. And there is, I have seen, because of this role where I am, I had a chance to talk with the architects of garbage collection, who has developed the garbage collections, who have given great, I've seen them talking, giving great talks on the stages. The moment they step down, if you ask them pointed questions, they scratch their head. Oh, oh, okay, that's what it is. Huh? Okay, I don't know. And I can even show you some very email communication from very senior architects in that JVM providers. They don't have the answer, because this garbage collection is such a deep ocean. It is such a deep ocean, and people all know only in their pockets of area. No one knows completely, and no one can say, "Oh, put this argument with this value, your performance will shoot up by this percentage." They can only give you some guidance, right? But don't worry. Uh, in next few minutes, I'm going to be share. Let me try to share as much as possible in the allocated time. Few simple techniques, few simple fundamentals. Using these fundamentals, you can also tune. You can also make your application performance a lot better, right? There is some few fundamentals. If you can grasp them, it doesn't matter. Today there is 12 GC algorithms. Let them go to 20, 25 algorithms. Let GC arguments go from 600 arguments to 1000 arguments. It doesn't matter. Let them grow, right? We can, by understanding these fundamentals, you can optimize it. Okay, so friends, when it comes to garbage collection tuning, right, there is some famous, it's true for any performance engineers, like if you want to optimize something, you need to know what you're measuring against. There is this famous saying, you cannot optimize what you cannot measure. So when I'm tuning for garbage collection, I need to understand what are my key performance indicators against which I need to be tuning. The first metric is called as GC latency. That is, what is the pause time? When a garbage collection event runs, it pauses your application. How much time does it pause? You need to understand that metric. What is the average pause time? What is the maximum pause time? And what is the distribution of them? Okay. And the next metric is called as the throughput. That is GC throughput. If what we discussed so far, it is a cumulative time. Cumulatively, how much time your application is pausing in a day or in a time frame. That's what it is. And friends, the third metric, these two are micrometrics. The third metric is basically the macrometrics, right? These two, what I'm sharing is a micrometric, the latency and the pause and the throughput is micrometric. And also you want to look at what is your macrometrics looks like. So when I make some GC setting changes, is my CPU consumption getting better or is it worsening? Where is my response time getting better or whether it is worsening? I need to understand those things, right? So let me show you one real world example. Let me share the screen for let me stop the screen sharing and let me pick up and show the current exercise that what we are doing for one customer. Okay, so how do I share that? How do I share the screen again, Naveen? Do you know? Hello,
think,
Naveen, are you there?
yeah, yes, Ram. Yeah, there will be a share button at the bottom. Are you able to find it?
Yeah.
Ram Lakshmanan, yCrash, joined.
Can you see my screen now?
Yeah, yes.
Okay, so okay, friends. So this is basically kind of the spreadsheet what we keep. So here we keep track of micrometrics, and then we keep track of macrometrics. So here we keep noting down. Um, here we keep noting down. So wait a minute. Okay, here is the micrometrics: the GC throughput, average pause time, maximum pause time. This total bytes, I'll talk about it. These are supporting metrics, but not very the supporting metrics. But the primary is the GC time, average time, and max time. And this is what is my CPU, the response time, and the transaction count. So this is kind of a spreadsheet we keep, right? And here we keep tracking. Okay, in this JVM setting, how much is it? My throughput. How much is my pause time? So now I will change the arguments and whether I see whether I'm getting better. If I'm getting better, then I go on that path. If I'm not getting better, then I retract and then I come back. So this is all the exercise we do. This is all the exercise we do. And when we do this kind of exercise or by few arguments changing, you will see the definitely you'll see a relief. There's nothing else, my friend. Even the very high paying architects or anyone, this is all they are doing. Nothing else beyond this. Okay. So now let's
These are
come back.
full GC or it's minor GC?
Okay, so and I mean, the minor see there is a misnomer in the industry. They say that minor GC does not pause the application. Only full GC pauses the application. That's not true. Minor GC also pauses the application. Full GC also pauses the application. It's just the minor GC pauses for a limited time period, and the full GC pauses for a longer period. So that's what it is, right? Okay. So now here I understood these are the metrics that I want to be tracking against. So how can I source these metrics? See, friends, these macro metrics you want to source it from your current monitoring tools, whatever you are using. Like if you're using load runner to respond to get the response time, go for it, or using the logs or any APM tools, then you go for it. The same thing, whatever you're doing, do it. But these micro metrics has to be sourced from the garbage collection log. How can you get it from the garbage collection log? You can get it from the garbage collection log by passing these arguments, right? By passing these arguments, when you pass these arguments to your JVM, it can generate the GC logging for you, right? It generates a GC log file and it's returned. If you're running from Java 1 to Java 8, this is the argument you want to pass. And starting from Java 9, this is the argument you want to be passing to generate the GC log. This is the file path where you want to be writing your file, right? This is where the JVM will write it. And friends, we have published white papers in our blog, blog.gcec.io. You can take a look at it, where we say enabling the GC log in all production environments, all production instance will not add any noticeable overhead, right? Uh, uh, the APM tools, they say they add only 2 to 3% overhead, which is an outright lie, which is an outright lie. And but they keep on saying, but but we add it and we do it. But GC log, you can validate. It's only few kilobytes of information it's printing. It doesn't add any overhead. And but for the advantages what we discussed, it's very fruitful to enable it and then diagnose the problem, right? Okay.
So,
Now,
Ram, Sid
go
has
ahead.
a question regarding
Hmm?
if there is no full GC for 8 hours, is it
Hmm?
good performance?
Not necessarily. It is a good indication, but not necessarily. What if you're having a minor GC and your minor GC is pausing very frequently, right? Let me show you a graph for that where it may be helpful to answer this question. So, Naveen, okay. I mean, I think we have only 7 minutes, but I don't think we can cover all the tips to tune the GC. Maybe we may have to do another sequel to this, but I'll just show how to get these metrics and let's stop it here. And the tuning, the tips to tune and all those things, maybe we need to keep it as a separate part, right? So now let me show you how to get these. So now these metrics are here, but these GC logs are very tedious to understand. It's very cryptic. This is how a GC log looks, all numeric gibberish, and it is also not standardized. This is how another GC log looks. A CMS, a different format looks. An IBM, a different JVM vendor. This is how their GC log looks. So there are so many GC logs formats. So you want to use any GC log analysis tool to study this, to get these metrics, the micrometrics. So here I've listed few of the freely available GC log analysis tool. So like GCEC tool is the tool that our company makes. And there's also this GC viewer and IBM as a tool, HP as a tool, Google as a tool. You are welcome to use whichever tool you want. I'm not going to say which tool is the best tool because obviously my opinion is going to be biased. Okay. So now let's say once I enable the GC log, once I have the GC log, this is how a GC log file typically looks, my friends. Let me.
Yeah, all I see is a J meter.
What do you mean?
Oh no, all I see is J meter, HP J meter.
Yeah, that's a good tool, but it works only for few JVM versions. Okay, so
Since we have a Apache J meter, right? So that's why.
yeah. Okay, got it. See, let me open this file. So this is how the GC log file will look like typically, right? So now what I will do, let me upload this GC log file into our tool. You can use any tool that what you want, but for our demonstration purpose, I'm going to be using the GCEC. So you can just come in here. You don't need to register or anything. You can just come in and upload your GC log file, right? I just selected my file and uploaded. There's also REST API available to do programmatic analysis. So when I upload it, here it gives recommendations of how to fix few problems and JVM settings, what you want to pass. But very importantly, here it's going to show me what is my throughput of my application and what is my pause time, the micrometrics, what we are looking for. And it shows this graph, what is the EAP usage going on. And then one of our friend was asking, my application is running without any pauses, full GC pause for 8 hours, right? The last question from our friend. So is it something I don't need to worry about? Look at this, friend. The red triangle here indicates a full GC event. This green square indicates it's a minor GC. Look, the minor GC is taking 74 seconds, but even the full GCs are not taking that much time. This is not the typical case, but it will happen. Sometimes a minor GC may take much longer than the full GC, right? So here you get this kind of behavior, right? So you don't want to always judge that full GC is bad, minor GCs are good. No, what you want to be focusing on, leave aside whether it's a full GC or minus GC. Focus on whether is it how much time that GC event is pausing. That's of more interest to me as a troubleshooter, as a tuner. How much time it is pausing, whether it is pausing for a few milliseconds, a few seconds. So that's what of interest. Okay.
So basically, the throughput is our critical factor to monitor, right, Ram?
Throughput and then this average pause time,
Pause
the
time.
GC individual pause time, right? So what if I have a very good throughput, right? But let's say, look at this. This pause time is 74 seconds. That means 1.5 minutes, close to 1.5 minutes, right? It is no 1 minute and 15 seconds. It is pausing. That means for 1 minute and 15 seconds, any transaction that is coming in time is not going to get any response, that customers, because it is pausing your application. It's a negative impact. It can violate your SLAs. Okay. So friends, now we have just 2 minutes left. So here we have come to a point we understood the benefits of garbage collection and what are the metrics I need to be using for tuning and how to source these metrics. But I wanted to share about how we can optimize the GC performance, the tips and tricks to optimize. But maybe I think we have to do it as a separate session, right? Okay, so but I'm here to take any questions for anything for next 2 minutes, right?
Yeah. Thank you, Ram. Thank you for sharing your insights, your knowledge for free. I know you charge the hundreds of dollars for 1 hour consultation.
No, I don't chat. Definitely not.
I'm just kidding.
Uh-huh.
Sure. So Siddhis asking one question: will it be same for both full and partial GC, the pause time?
Maga Lakshmi said, see, this is a good question, but to answer this is going to be a little bit more time. So, but anyway, we'll take time. Is it okay, Naveen, or what do you
Yes,
think?
sure.
Like,
Yeah, you
okay.
can take, please.
Okay, so let me go ahead and share this screen and let's talk about it. See, friends.
yCrash joined.
Okay, friends, one GC event, right? One GC event has multiple different phases. Just one GC event, just one event has multiple phases, right? One phase is called as init mark. Other phase is called as a concurrent mark. And then it has a phase called concurrent sweep. And then there's a final mark. And then a remark. And there are a few more phases. In all these phases, most of the phases runs concurrently along with your application threads. It runs concurrently along with your application. It does not pause your application. It does not pause. Only few phases like this init mark, like this final remark or this remark, they pause your application. Others can run concurrently, right? So when we report here, look at this. Let's go back to our graph. When we look at this graph, in our report, we publish two graphs. One is this GC duration and other is this pause GC duration. What is the difference in between them? Look at this. Here, there's this full GC event. It took like 37.84 seconds, right? It ran at 4:28:44 a.m. Now, here is this pause GC duration. So this graph shows the so this event, even though it took like a 37 seconds, in this pause graph, I look the same red triangle, which ran at the same 4:28:44 a.m. It's taking only half a second, 0.5 seconds. So the all those time, this is the only time it pauses. The remainder time, like say, even though it took like a 37 seconds, the majority of them, like a 37.3 seconds, run concurrently with the application. Only 0.5 second paused. So for all calculations and everything, you want to be looking at only a pause GC duration graph, right? So, I think, I don't know whether it answered your question, my friend.
Yeah. Thanks,
Okay.
Ram. I guess, yeah, we have not no more questions here. And many thanks again. We will definitely schedule one more session to the sequel so that you can share
Yeah.
more insight about this.
Okay.
So I have some few questions to you.
Sure.
So what is your favorite GC? Do you have any favorite GC algorithm?
See, I don't honestly. I don't have a favorite GC algorithm. It depends from application to application. See, there's no one. Uh, there's no, when people say the only tool I have is a hammer, then all the things will start to look like a nail. That's a thing, right? So it depends on your application. It depends on the traffic pattern what you get, and it depends on your heap size. On all those things you get to decide. But the G1 has now become the default. Now in Java 8 plus, if you're running, that is the default algorithm, right? But I don't have any preferred GC thing. In fact, like for some cases, uh, look at this. I yeah, I will talk about it later, right? You don't have to change the GC algorithm. Even without changing GC algorithm, by changing few other settings or changing your generation size, you can get phenomenal improvements, right? Those
Correct.
things we'll talk in our sequel.
Yes. Actually, I was working for a retailer, previous company. So I was talking to one of the architect. So he was saying we don't touch anything with respect to GC algorithm or the arguments. We just run it with the default settings.
Yeah,
If there is any problem, then we dive into it and see whether it can be tuned or not.
right, right. See, that friend is right. That architect is right, right? But how will you know if I bought a car and I'm driving the car, and if it's dropping, if it's passing for every 10 miles, then I will know it is a problem. You will not
Yes.
know whether it's a problem or not unless you take the GC log and look into it, right? Because it is passing. So, but I agree with the suggestion. For most of the cases, the default itself will be fine. Sometimes I have seen people add unnecessary arguments and they make it counterproductive, and then they degrade application performance.
So Pawan has one last question, I guess. So do you recommend to move to the latest Java version for better performance?
See, I don't want to be on the very latest one because the latest Java version has some issues unless it is stabilized, right? So, but typically the modern versions, they keep the garbage collection performance keeps improving. Uh, so I don't have a hard and fast answer to this question, right? But typically you don't want to be on a very deprecated, very older version. Probably you want to be on a little modern version, but not on 18, which is more recent, rather a little bit 11, 12 or something like that. Yes.
Yeah, most of the enterprises they are in 11.
Yeah.
They don't move to latest version unless it's a need.
Right. Right.
Cool. Yeah, thank you, Ram. Again, yeah, probably we can schedule something probably whenever you are free. I know
No,
you're
I think
busy person.
no, we can do. We'll schedule something very quickly, right? So that not lose the stream.
So the
Okay.
people can
So
learn continuously. Yeah.
right, right, right. Okay. So, friends, first of all, thank you everyone, and thank you Naveen for giving this opportunity. And I'm hugely honored. And friends, thank you for taking your valuable time, your weekend, and coming and listening here. Thank you.
Yeah, thank you. Thank you everyone for joining,
Okay.
for the excellent questions. Yeah, we will come up with some new topic next week. So I thought of scheduling more live sessions in future. So please stay tuned. Thank you.
Okay.
Have a good week.
Thank you, friends. Yeah. Bye.
Bye.
Mm.